This is my submission for assessment video 8A. So the question asks, a 40 kilogram crate, the figure is traveling to the right with an initial velocity of 1.2 meters per second. When a person begins to pull on the rope with 200 newtons at an angle of 30 degrees from the horizontal, the coefficient of kinetic friction is 0.3. Draw a free body diagram of the block and calculate all forces on it. What is the speed of the crate after it is pulled 20 meters and how much thermal energy was created? So let's start with a diagram. We know that we have a box, and obviously there's a force down, which is mg, and that's going to cause a normal force upwards of the same magnitude. And we also have our friction force, call it Fk. And lastly, the most complex, we have the rope pulling on the box, and it's at an angle of 30 degrees. Now this is going to have a vertical and horizontal component. The horizontal component is T cosine theta, T being 200 newtons, and the vertical component being T sine theta. Now let's look at what we're given. Now we know the mass of the box is 40 kilograms. Gravity is 9.8 meters per second squared. Acceleration, the tension force is 200, pulling on the box. Coefficient of friction is 0.3. Displacement is going to be 20 meters, and the initial velocity is 1.2 meters per second. Now let's try to figure out what is the values for some of these forces. So we know mg, we can find that as the mass 40 kilograms times 9.8 meters per second squared. That's going to give us 392 newtons, which will be mg, as well as the normal force. Now we also have defined the friction force. Now friction force is not as straightforward in this example, as it's going to equal the coefficient of friction times the normal force, mg, but it's also minus the vertical component acting on the box, because that component is basically helping pull the box upwards and reducing the work friction is doing. So that's going to be T sine theta. Solving for this, we can just plug in 0.3, 40 kilograms, 9.8 meters per second squared, minus 200 newtons, sine 30. Simplifying that, we're going to get the answer of 87.6 newtons. We'll also solve for the horizontal component, T cosine 30, which is equal to 200 newtons cosine 30, which will equal 173.20 newtons. This will come in handy later as we find the final velocity. As we know, the equation, we know that work is equal to force times displacement, as we learned that in physics lecture. And we also know that the net work is equal to the change in kinetic energy. We'll use these two equations to find the final velocity of the box at 20 meters. So first, let's find the net work. So we can have the work. We know that the box is being pulled forward and is also being held back. So we'll do the forward force work minus the backwards work being done by friction. So we can represent that as T cosine theta times the displacement minus T sine minus the friction force, which is going to be actually the coefficient of friction times the normal force mg minus T sine theta. And then we're going to set that equal to the change in kinetic friction, 1/2 mv v final squared minus v initial squared. Now we have every value in this equation except for v final, which is what we're going to isolate. And that we'll just do algebra. We'll multiply everything by 2 on both sides, divide by m, and then add vi squared. So we'll do that right now. 2t cosine theta times d minus coefficient of friction mg minus T sine theta, all divided by m, adding the initial squared, and then we're going to isolate b final squared by square rooting both sides, and this will be the final equation. At this point, we can just plug in values. We know T is 200 newtons, cosine 30 times 20 meters, the displacement, minus kmg. Oh, I actually forgot a very important value. I forgot to put d here. There's actually a d multiplied to the second work force of friction. So that's important. So it's going to be minus 0.3, 40 kilograms times 9.8 meters per second squared, minus 200 newtons sine 30, that times 20 meters. Now I'm running out of space. Hold up. Okay. That times 20 meters, all divided by 40 kilograms. Of course, adding the initial 1.2 squared. And that's what we have to solve. And that's going to give us a final answer. Solving for all of that, we're going to get a speed of 9.32 meters per second. That's going to be the speed. Now, for the second part, the thermal energy, we were taught that thermal energy is equal to the friction force times displacement. And that is simply going to be 87.6 times 20 meters, which is equal to 1752 joules as the thermal energy.